Alrighty, so now we would like to have a look at what happens when these 2 points get really, really close together. And we want to compare how a secant, which is an approximate, compares to actually trying to work out the tangent line and then working out the slope of that. So what we're trying to do is we're trying to work out an approximate slope at the tangent to the point A. So what is the gradient at point A? And we can approximate it by looking at the secants AC and then at AB. Now point C is 0.4 away. And so the way we can use this is what we call a H value. And a H value basically allows us to control how far away the next point we're interested in is. In this case, you can see this one's 0.4 away. Point B has a H value of 0.2 because it's gotten a little bit closer to point A. Alrighty, so let's have a look. Now this function here is what we're going to be using in a bit. It's part of our first principles formula, which is how we actually calculate derivatives. So it says we're going to evaluate the function at x plus h. We're going to subtract the function at x over the height, or this h value. And we can see on the picture, what does that actually look like? Well, this is f of x plus h, and this is f of x. So this side length here, the height of this triangle, which is how we're going to work out our gradient, is f of x plus h minus f of x. Whereas down here, that's just the h over here. That's this 0.4. Similarly, we can do that for the secant AB. The height of this is f of x plus h minus f of x. It's the difference between the two y values over h, which is the difference between the x values. So let's calculate a few of these. So f of x plus h minus f of x, well, f of x plus h alrighty, well, x is equal to 1, h is equal to 0.4, so we get f of 1.4 minus f of 1 all over 0.4, which is 1.4 squared minus 1 squared. Notice the function itself is x squared over 0.4, which in our calculator computes to 2.4. Alrighty, for part B, let's do this again, but we're keeping x the same, we're just changing the h value, so h is getting a little bit closer. So let's try this again, but with 1 plus 0.2 minus f of 1 all over 0.2, because our h value has decreased. So it's 1.2 squared minus 1 squared over 0.2, and this time we get 2.2. So it's gotten a little bit smaller. So that means that the secant AC is a little bit steeper than AB. Not by much, but this is a little bit steeper than this, which isn't too surprising. But now let's have a look at part C, which determines the gradient of the tangent. So we need to draw in our tangent line, which to my eye looks about right there. And there we're going to work out the gradient of this tangent line. So we were using secants before, but let's use it. So we've got 1, 1, which is our first point, and this is another easy point to read off. So 1.3, 1.6. So let's work out the gradient of this one here. Alrighty, so we get 1.6 minus 1 over 1.3 minus 1, which is 0.6 over 0.3, which is equal to 2. So we can see that our approximation got better as h got smaller, and then when we actually drew the tangent line, we got something that looked exactly like 2. So for part D, explaining how these gradients actually relate to each other, well, A and B are both approximations but they get better the smaller h is. right? Because obviously our tangent line, this tangent line here, is a much better approximation than the line AC. So if we can actually get a tangent line, we're always going to get a better approximation. Next chapter, we're going to look at even better ways of doing it. Alrighty, see you later.